Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. In our last lesson, we looked at properties of polygons, right, which could be figures made up of 3 or more sides, with some other things that had to be true. Today we're going to look at a type of quadrilateral. So we're going to look at a parallelogram, which has 4 sides, and it is going to have some other characteristics, but we'll get into those in a few minutes. First, start these two review problems. So in number 1, you're trying to find the value of x and y, and in number 2, you're just trying to find the value of z. So pause the video, do those real quick, and then join us back for a discussion. All right, so for number 1, we do know that these two red lines are parallel, right? They have these little arrows here which show that they're parallel. And these two angles here are the two angles that have an x in them. So we need to see what the relationship is, right? And those are both inside the parallel lines. They're on the same side of the purple transversal, which means they are same side interior, which means they need to add to 180. So 61x plus 29x is equal to 180. That gives me 90x is equal to 180. And x must be equal to 2. For the two angles on the other side, we have a pink transversal. And these angles are on opposite sides of that transversal, right? They're still both inside the parallel lines, but they're on opposite sides. These are alternate interior, which means they are congruent. So I get 8y is equal to 6y plus 8. That gives me 2y is equal to 8. And that gives me y is equal to 4. A little review from Unit 3. Little review from Unit 4. We have a right triangle. So we know that this angle is 90 degrees. And we have the triangle sum theorem going on here. So we have z plus 72 plus 90 is equal to 180. Right? We know that all three angles of a triangle should add to 180. So I get z plus 162 is equal to 180, and then I get z is equal to 28 degrees. Okay, let's now move on and start our discussion on parallelograms. So a parallelogram, put quite simply, is a quadrilateral with two sets of parallel sides. Parallelogram, right? It has the word parallel in it. It's because opposite sides are parallel. So this is a definition that you are going to be able to use in proofs. If you know that something is a parallelogram, well, you can say that opposite sides are parallel. You can also go the opposite way. If you know that you have a figure and you've proved that opposite sides are parallel, well, then you can go ahead and say that that figure is a parallelogram. And both of these fall under the definition of a parallelogram. You know, it's one of those definitions that works both ways, right? Definition of congruent angles, definition of congruent segments, etc. So let's go ahead and prove some other properties of parallelograms. One property, or actually the definition, says that they have opposite sides that are parallel, but there's also some other properties that we can show that are true for every parallelogram. Again, parallelograms have many key properties that we can use to find missing angle and segment measurements. Before we apply those, I want us to prove them, right? So we understand why they are actual properties. So our first theorem is that if a quadrilateral is a parallelogram, but basically what that is saying is if a four-sided figure is a parallelogram, then opposite sides are congruent. Now the definition says that opposite sides are parallel, but we want to try to prove that opposite sides will also be congruent. So that's what this proof is going to show. So we are given a parallelogram, right, A, B, C, D, and we need to prove that opposite sides are congruent. I'm going to have you walk through this proof on your own first. I do give you a little hint. It says draw diagonal AC to help. And then when you think you have it, join us back and we will go through the different reasons. Okay, so it does say draw diagonal AC. I will just put that in there right away. We are going to use it. So the first statement says ABCD is a parallelogram. Well, that of course is given. Then I'm told that segment AD is parallel to segment BC, and segment AB is parallel to segment DC. Well, that's just definition. I guess you guys are going to see how good my typing skills are today, or bad. Again, definition of a parallelogram, that's what we talked about above. Then we are told that angle DAC is congruent to angle BCA. So let's mark those. Angle DAC is congruent to angle BCA. Well, why could those possibly be congruent? Well, we just proved that BC, right, and AD were parallel. Well, if those are parallel, then alternate interior angles must be congruent. So alternate interior angle, angle theorem. Now again, we had to show that those lines were parallel before we could use this. We are then told that angle DCA is congruent to angle BAC. So DCA, BAC. Well, same idea. These two pink lines, we've already proved that they are parallel. So again, alternate interior angles are going to be congruent. Okay, we're then told that segment AC is congruent to segment AC. Well, anything is going to be congruent to itself through the reflexive property of congruence. And look at what we've just created. We have triangle ADC. I'll highlight that in blue. ADC. That's going to be congruent to triangle CBA in green. Let's do light green. And let's think about which congruence property proves it, shows us that, right? Which of those acronyms proves that these two triangles are congruent? Well, right here we have two angles in one side that are shown to be congruent, which means that we are using ASA because the side is in between the angles. Otherwise, it would be AAS. Well, once we've proved that triangles are congruent, we can prove that corresponding parts of those triangles are also congruent by CPCTC. And we've just proved what we wanted to, right? We have shown that DC is congruent to AB and AD is congruent to CB. So opposite sides of a parallelogram are always going to be congruent. And now that's a property we can use later on, whether it be in diagram problems or whether it be in proofs. Let's move on to our next one. Okay. This new theorem is if a quadrilateral is a parallelogram, then consecutive angles are supplementary and opposite angles are congruent. So we're actually going to knock out two properties in one proof. So we're given that ABCD is a parallelogram, and our final thing we're going to prove is that angle A is congruent to angle C. But inside of this proof, we're also going to prove that consecutive interior angles are supplementary. And I know it doesn't say consecutive interior angles here. That's because they're saying that if we talk about consecutive angles in a figure, that just means two angles that are next to each other. So if I look at my figure, right, consecutive angles to A could either be D or B, right? A and B would be considered consecutive, and A and D would also be considered consecutive. So we're going to prove that consecutive angles, regardless of which ones they are going to be supplementary inside of a parallelogram. Okay. Again, pause the video, try this on your own, and then come back and see how many of these you got right. Well, first statement is, of course, given. ABCD is a parallelogram. The next statement is showing that opposite sides are parallel. And of course, that is definition of a parallelogram. Then we are told that D and A are supplementary. Well, we were just told that opposite sides were parallel, or rather we just proved that. So what theorem tells us that consecutive interior angles are supplementary? Well, it's the consecutive interior angles theorem, or same side interior angles theorem. Let's put consecutive here today. Consecutive interior angles theorem. They're also asking us, well, they're also saying that we can prove that D and C are supplementary. And of course, we can prove that because we already proved that CB and AD were both parallel to one another as well. Okay, so that kind of knocks out the first part of this theorem, right? We were trying to say if a quadrilateral is a parallelogram, then consecutive angles are supplementary. So we've done that. We could have also listed, AB and CB being supplementary, but I think it's clear that, any pair of consecutive angles here in the parallelogram is going to be supplementary. They just chose to show AD and DC, but we could have also gone ahead and said CB and AB are as well. Again, based on the fact that we have parallel lines. Now we're going to work through the rest of the proof to show that opposite angles are congruent. So once we know that these angles are supplementary, well, we can say that they have to add or sum to 180 based on the definition of supplementary angles. Next statement is bringing these two equations together, right? I have both of these sums equaling the same thing, so I can set them equal to each other by the transitive property of, spell property correctly, property of equality, or POE. And then you'll notice that we have a measurement of angle D on both sides here, so I can subtract that from both sides. Subtraction property of equality to get that the measurement of angle C is equal to the measurement of angle A, or vice versa. I should spell subtraction right, shouldn't I? Subtraction. And then I can always go from the measurements of two angles being equal to the two angles being congruent by the definition of congruent angles. We could also, again, I know that we've only proved that angle A is congruent to angle C, but using the same process, we could also prove that angle D is congruent to angle B. For the sake of time, we're not going to go through that. Just know that, again, same idea would apply to show that angle D is congruent to angle B. So consecutive angles in a parallelogram are always going to be supplementary, and opposite angles are always going to be congruent. Let's look at the next one. This is going to be our last one for the video. This theorem says if a quadrilateral is a parallelogram, then the diagonals bisect each other. Okay, so I already give you a little hint. We're going to need to draw the diagonals DB and AC in, and you can label that intersection as point E. So again, we're trying to prove that if it's a parallelogram, then the diagonals will bisect each other. Go ahead, work through the proof. Make sure you sketch in what you need to help you visualize it, and then join us back for a final discussion. All right, so I'm going to draw in my diagonals first. I have AC, and I have DB. I'm going to label that intersection point as E. So first statement is our given. Our next statement says that segment DC is congruent to segment AB. So let me put some tick marks there. DC is congruent to AB. Well, and I wrote this reason in because it's one of our newer ones, but we just proved up above that opposite sides of a parallelogram are congruent. So if we know that the figure's a parallelogram, we can write in that opposite sides have to be congruent to one another. Our next statement is that segment AB is parallel to DC. AB parallel to DC. Well, this goes back to the definition of a parallelogram. Right? Opposite sides are parallel. And if I know that AB is parallel to DC, well, then angle BAE, this angle right here, must be congruent to angle DCE, right here. And again, that's due to the fact that these lines are parallel, and those are alternate interior angles. So the alternate interior angle theorem. I then say that angle ABE is congruent to angle CDE. This is nice because we're still using the same set of parallel lines, just a different diagonal, the blue diagonal, but they are also alternate interior angles. So we're going to use the alternate interior angles theorem. Let's put an S there. Well, I do have enough to now show that triangle AEB, let's outline that in orange. Triangle AEB is congruent to triangle CED. And that's going to, again, be by angle-side angle congruence, ASA. Once I know that two triangles are congruent, I can prove that their corresponding parts are also congruent by CPC-TC. Right? I can prove that side DE is congruent to side EB, and I can prove that side AE is congruent to side EC. Well, once I've done that, I've shown that those diagonals have bisected each other, right? Each half of the diagonal is exactly half of the entire segment. So again, just another property of parallelograms. We are going to stop the video here. We are going to do some of the application problems down below where we use these properties to solve for different angle or side measurements. But now you have the tools to be able to do that, and more importantly, you know why those tools actually work, because we've proved them. Okay, enjoy the rest of your day, and I will look forward to seeing you next time.